You guys all had a great weekend. We are back ready to finish Indicator 15 this week. We have 2 more days of notes, and then we're going to do some review, and we will be quizzing on Friday, just to give you a heads up. So we are solving equations with elimination again today. However, we are going to see things today that aren't going to be able to eliminate right off the bat. We're going to have things that look like this. So we have an x term, a 5 and a 3 do not make 0 in any way, shape, or form, whether you add or subtract the numbers. Same thing with 2 and 6. And so we actually have to do a little bit of work in order to make these eliminate. So it's not difficult work. So we just have to ask ourselves, look at the x terms. Does 3 go into 5? And the answer is no. But let's look at the other numbers. Does the y's, does 2 go into 6? And the answer is yes. And if we look at this, we already have a -2 and we have a +6 here. We always want opposite signs to eliminate, so this is good. But we want this 2, we actually want this to be a 6. So we are actually going to figure out what would I need to multiply this by to make 6? And the answer is 3. 2 times 3 is 6. So just like we did yesterday or on Friday when we changed signs in order to eliminate, if you do something to one, you have to do them to all. So we're actually going to multiply this by 3 in order to get that 6y, but we have to also multiply that 5 and that -10 in that top equation to make it work. So my new top equation, if I multiply everything by 3 times 5x gives me a 15x. Then I get a -6y, which is what I wanted. And then 10 times 3 is a -30. So don't forget to multiply all of the numbers by that. Then right here, my bottom equation didn't change at all. So now we have a +6y and a -6y that eliminate. That's the goal. So then we just add what's left. 15 plus 3 gives me 18x. -30 plus 66 gives me a +36. So then I can divide by 18 and I get x is 2. Fantastic. Now, we just pick an original. I don't care if we pick top or bottom. I'm actually going to go with the bottom. Just, again, I don't like to work with negative numbers if I don't have to. Some people might choose that top equation just because numbers are a little smaller. But I do know my x is 2, so I can plug that in. So then I get 6 plus 6y equals 66. And subtract 66 minus 6 is 60. And I divide here, and I get y is 10. So my ordered pair of my solution where they cross is 210. And you can always check those on Desmos, but you can also check it algebraically. So guys, this is just another way that you can check, not a requirement, but I'm just showing you. If x is 2 and y is 10, you could simply plug these in and see if it works. So I want to know, is 5 times x is 2 minus 2 times y, which is 10, is that equal to -10? Is 10 minus 20 equal to -10? Absolutely. All right, now try it on the bottom one. Is 3 times x, which is 2, plus 6 times y, which is 10, is that equal to 66? 6 plus 60. Is that 66? You betcha. So you can check algebraically. You can check using Desmos. You can really risk it and not check your work, but that's totally on you. Not recommended. So let's do a couple more where we have to multiply. The easiest way, like you just look at your numbers and like you just ask yourself, like, does 5 go into 3? No. Does 2 go into 6? Yes. So that's the one you're going to multiply. So we'll do a couple more. All right, I got 7x plus 4y equals negative 4. And my bottom equation is 5x plus 8y equals 28. All right, so I got to ask myself, does 5 go into 7? The answer is absolutely not. But does 4 go into 8? And the answer is yes. So on this one, we're going to multiply this top equation. We're going to make the y's eliminate. So right now I have a positive 8 here. So I want my other y, I actually want it to be a negative 8. So I think everybody probably knows that 4 times 2 is going to give me the 8. But right now I have a positive. So I actually need to multiply this by negative 2 in order to get the negative 8. So then my new top equation is going to be negative 14x minus 8y. Now 2 negatives will turn this into a positive 8. And then my bottom equation will stay the same. 5x plus 8y equals 28. So now we're ready to do some work. We got those to eliminate. That was the whole point of doing that multiplication. So now I have a negative 14 and a positive 5. So if I add those, I get negative 9x. And then 28 plus 8 is a 36. So if I divide by negative 9, positive divided by negative gives me a negative 4. So then you can pick your top or bottom. Again, that's a personal preference. I'm going to go with the top. I'm choosing it this time because of smaller numbers. All right, so if I plug in a negative 4 for x, I get negative 28 plus 4y equals negative 4. So when I add my 28 over, I get 4y equals 24 and divide by 4, and I get y is 6. So my ordered pair is 4, 6. And again, we could check by Desmos. You can check by plugging in x and y to each equation and making sure it's got to work for both, not just one. And there we have it. Okay, here we go. X plus y equals negative 9. 5x minus 2y equals 32. Okay, on this one, you actually have 2 different ways that you could do this problem, and I'm going to actually show you both ways here. All right, and the reason why our coefficients here, one goes into 5 and one also goes into 2. So you just have to ask yourself, do you want your x's or your y's to eliminate? So if I have a positive 5 here, I can make the x a negative 5 on top if I multiply by negative 5. So I'm going to actually just rewrite this bottom by multiplying. 2 negatives would make it a positive 45, correct? So then you would eliminate, and we would get negative 7y equals 77. So y is negative 11. And then to plug it back in, I would probably go with the top equation just because there's no coefficients, a little bit easier to solve. So I know x, I know y is negative 11, so I'm going to write minus 11 equals negative 9. And then I'm going to add it over, and I get a positive 2 for my x. So I got positive 2, negative 11. Now, on the other hand, I did the work here. I made the x's cancel. You could also make this where the y's cancel instead. So if you didn't want to multiply everything by 5, if this is a negative 2, and we want this to be a positive 2, just multiply by 2. All right, so you are going to see here what happens. All right, the y's eliminate, and you get 7x equals, and then 32 minus 18 is 14, and then you get x is 2. So it doesn't matter which which variable you solve for first, just whenever you go to plug it back in, make sure you plug it in for the right number. So it's going to go in here. 2 plus y equals negative 9. Subtract your 2, and you get y equals negative 11. You get the exact same result. It is totally a personal preference on which one you multiply. So you just had to decide, do I want this to be a negative 5x, or did I want that to be a positive 2 to cancel with the y's? And again, totally does not matter. I can't hesitate, or can't stress that enough. It does not matter. It's going to be very hard to have identical work to somebody, because if you multiply different, it's okay. You're going to get different. Your work's going to look different, but you're going to get the same result. All right, and then the last thing I want to remind everybody is if you have something that looks like this. I don't know why I put a Y there, and I shouldn't erase with my finger. See, you don't do that. All right, do you guys notice anything about those equations? Let's say, does 3 go into 6? Yes. Does 4 go into 2? Or 2 go into 4? Yes. All right, so if this is a positive 6, I want this to be a negative 6. I'm going to multiply by negative 2. So I don't like to, when I multiply by the bottom, I always rewrite the equations just because I don't like to mark out the originals. Oh, look at what happens here. So on this one, once I multiplied, my 6 is canceled, my 4 is canceled, and my 24 is canceled. If you guys remember from Friday, what does it mean when everything eliminates and you're left with a true statement? True statements mean that they graph to be the same line, and so it's infinitely many solutions. Infinitely many. Now, what if I'd given you something like this? Now, if you look here, I would need to multiply to get one of these to eliminate. So if this is a positive 4, if I want to make the top a negative 4, I'd multiply by negative 2. And I'm going to rewrite it down here. Negative 4x minus 14y equals negative 10. My 4's cancel, my 14's cancel, but I'm left with this. Whenever it's different numbers and it's a false statement, don't forget that that's a no solution. So those are the difference between those two. Again, we're going to add one more step tomorrow, but if you have any questions on what we did today, don't hesitate to ask, and I probably should clear that up. I did multiply by a negative. Sorry, that cut off. So if you have any questions, don't forget to email me or ask to do a Google Meet, and we can do some one-on-one help. Yeah, so guys, one more day of notes forever. So tomorrow's lesson, we'll be multiplying both equations and not just one, but they all tie together. It's the same process once it eliminates. So it's really just adding one itty-bitty step, and I'm ready. So one more day of notes before Christmas. I think that's a Christmas present in itself. I hope you guys all have a great afternoon.